this is a little thing I ordered a couple weeks ago from Banggood. It's a square wave generator. Just very simple little thing, but it goes up to 150 kilohertz from 1 hertz all the way up, and then it has duty cycle of 1 to 9 to 90 or 100%, so it could be fully on. Got my power coming in here. I got it at 10 volts. You can see on the scope here, 5-volt scale, showing just a hair above. I don't know why. Maybe have to measure that. But this is basically the top number. If it shows 1 decimal point like that, it's in the kilohertz. If it shows a decimal point between both digits, it's in the 100 kilohertz. So this is at 10 kilohertz at 1% duty cycle. Just stretch it out a little bit. You can see there's a little slope on the beginning there, but close it all in. Excuse me. And you can see it's 10.07 kilohertz. It seems to be that scale of a difference all the way up to 100 kilohertz. But either way, we can take this and increase the duty cycle so we can see that here. If you hold it down, it starts to speed up, sort of like other electronics. So right there, we're at 100% duty cycle. -1, we'll scale out, and that's your reverse wave. And let's bring it to 50%. Doesn't take too long to get to where you need to be. Pretty decent. Okay. And let's take it up to 100 kilohertz. So that's like 42 kilohertz right there with 1 decimal point. And when we get to the point where, see, that's 150 kilohertz right there. We might as well just stay right there. Let's look at this. We're at 50% duty cycle. I'm going to change my scales here, my timing. And at 50% duty cycle, this is what the wave looks like. It's pretty straight. Focus in on it. Has a little slope like we were talking about. But 150 kilohertz, 10 volts. Right here it says 152. Let's see. Let's get some more on there for sampling. It says 152. So it could be the scope. Could be this thing. Now we'll take it. We're going to take the duty cycle down on this. Let's get this out and look at it. You can see it does a digital shift as it does each duty cycle. Let me move this over a little bit. Zoom in on that. So that's 5% duty cycle at 150 kilohertz. It's probably not the nicest square wave, but we can look at them all here. They're all there. So we'll go down to, this is where it starts to really drop off. Down to 4% duty cycle, 3%. Can't really do it. Just a little pip there. That's almost 10 volts. And bring it down to 2%, and can't even see it anymore. So it can't do 2% and 1%. Let me see, it's possible. It's just lost the trace space because it's so small at 2%. Let me see. Plus, okay, we got it back. Let's try to bring it down, and bring it down to 2%. No, it can't produce that. So there's limitations with the very high frequencies. But I got this for simple square waves for pulsing different things. Like a lot of these electric bike motors, they use 15 kilohertz in their PWM. So I like to stay in the audio and maybe up into the 50 kilohertz where it actually looks pretty good. I'll bring it down to 50. I'm going to put some external switches on this, but it's so cheap you can install it into a project permanently, and it remembers its program, its settings when you take away the power. It was, like I said, $3 off of Banggood, but it took $10 and 2 weeks to get here. You can get it on Amazon tomorrow for less than $10. Okay, we're at 50 kilohertz at 2% duty cycle. Let's see. Okay. And we go to 1%. We're still can't do it. So some of the frequencies that I intend to really use in 1% is down in 12 kilohertz, like I showed you, around 10 kilohertz and less. So this thing will work pretty nice, and as I adjust this voltage here, up and down, this voltage goes up and down. Maybe just go all the way to 30 volts here. Take it just close. There it is. And things not smoking or anything like that. So your output is equal to whatever your input is, as long as the circuit can put that out. So change our duty cycle and our actual voltage. What's this saying? This is on 10 volt scale, just over 30 volts it's saying, at 33 kilohertz. So we give it some more to look at. Saying 50 kilohertz right there. Alright, just wanted to show that. Now what I gotta do is hook it up to some stuff and see what it can do. Is it going to be able to drive a MOSFET directly, or do I have to have a buffer circuit? I think it's very convenient that you can just change the input, or in a small circuit it works on any input from 3 volts to 30 volts. That's very convenient, and we'll see what we can do with this thing. Alright, thanks.